Welcome. My name is Spencer Gibb. Can you hear me all right, everybody? Back? Good. My name is Spencer Gibb. I work for Pivotal. I'll be presenting today with about Spring Cloud, which is I'm the co-author along with Dave Sire that has built Spring Cloud. Hope you find it useful, and I hope to show you some good demos. We'll try not to be in the slides the whole time, so we'll get to see some things running and breaking and things like that. So I work for Pivotal. These are some of the things that we do. Cloud Foundry. Of course, I'm on the Spring team, so that's what Spring Cloud is part of. So I titled the talk Cloud Native rather than Microservices. I've been thinking about it for a little while. I like the term a little bit better. That's my quote down at the bottom. Everyone understands what microservices are, but I think there's a little bit of a misnomer with micro and small. You know, I don't know that it matters in the number of lines of code or things like that. I think it's almost an organizational approach as much as it is an architecture, right? You want small teams that are able to think about small parts of the overall system and execute well on them, and you know, at some point replace them when they need to be, and have all these pieces in place for a truly cloud native type application. But I will use the term microservice just because everyone understands that. So one of the things that is required is that it's easy to spin things up. So Spring Cloud is based off of Spring Boot, right? This is the anybody go to Josh Long's Bootiful talk? Okay, or is familiar with Spring Boot? Besides that, great. This is the classic kind of tweetable app, right? Doesn't do anything useful, but it is easy to get started. So that's what we'll be building on. As I go through the talk today, be using an application that I've built partly for this talk today, but partly for myself as I'm building Spring Cloud to kind of validate what we're doing. I wanted something that was not trivial, that was a little more complex, trying to draw on experiences I've had in building things. So it's not too overly complex, but it's not just one or two servers, right? I'll have 8 or more services running, you know, up here shortly. So this is kind of the overall picture of what we'll be looking at. So I'll have a proxy in front of 2 different user interfaces, and a couple of services that drive those user interfaces connected to separate databases on the back end, just so everyone has an understanding of kind of what we'll be looking at as we build things. As you break apart, you know, a large application into these smaller pieces, it doesn't come for free, right? The app itself, the little component, the service itself, is easier to reason about because it's smaller and more focused. But complexity is added when you break up your system into smaller pieces, right? How do these, you know, pieces know how to talk to each other? How do you configure them all? How do you move them from one environment to another? How do you test them? How do you, you know, all sorts of things get more, you know, how do you deal with failure in one of those services? How do you, anyway, so Spring Cloud hopes to overcome some of those problems that you get when you build a distributed system like this. So some of those things that we'll be talking about is configuration. How do you configure all of these different services in a manner that isn't, you don't want to be doing things by hand. You want it to be automated, yet you want it to have traceability. Who made this change that broke production? And it was a config change, right? No one's ever had that problem before. Service registration and discovery, right? So I'm bringing up a new service. How do other services connect to it? I have n number of these, I have 10 nodes of service X. How do I know which one to connect to and things like that? Routing, not only from a client perspective, but internally, how do you route? There's some seats up front here, guys, if you want to come in. And there's a few here in the middle, too. So we'll talk about routing in both the front end and internal routing. Making those calls from one service to another, right? Rarely is it the perfect tree of calls, right? You end up having dependencies between services, and we'll talk some about that. Load balancing, I mentioned that a little bit. What strategies are there to decide which node to call? Circuit breaker, we'll talk about how to stop cascading failure. Right? If you've ever had a system that somewhere deep down in the pipeline broke, and for all intents and purposes your whole application was broken, but it's really just that one part. How can you protect yourself from that failure cascading all the way to the top? We'll get into a little bit about the asynchronous nature of these cloud-native microservice type architectures. We'll get into a little of reactive programming. I'm planning on going to the reactive session later today, so really interested in that. And a little bit about messaging and how you can do this sort of asynchronous communication that needs to happen in these kinds of systems. So building on the Spring platform, we have Spring, of course, is kind of at the base. That's not a foundation; it's the Spring framework itself. Like was said, we'll be building on Spring Boot, and Spring Cloud is kind of this thing that we hope that can bring all these separate applications together. So here's a little bit more detailed. Let me see if I can make that a little easier to read. Sorry, some of that text is a little small, but we'll be plugging in circuit breaker and load balancer at various places. We'll be talking about configuration for all of these services, this distributed messaging that we've talked about. Service discovery will be running, and we'll be able to show you some neat metrics that relate to circuit breaker. Questions, comments? Go ahead. If you have anything, just raise your hand and I'll try and notice you. So we've chosen to use the Netflix OS, some of the Netflix OSS stack to implement these patterns, and they have a great system, and they put a lot of time and effort into these different components that solve some of these problems. And with Spring Cloud, we hope to make it easier to consume these things, because on their own, sometimes they're a little daunting. And how do you start them? How do you bootstrap yourself with these things? And so we hope to make it simple to use. Netflix has been traditionally a Juice house. A lot of their applications are moving to Spring and to Spring Boot, so they are moving in this direction. We'll talk about those top 6 down to Arceus, and they have this is only a fraction of their open source suite. If you've never gone to their GitHub page, go look at their account. It's impressive what they've released. And I was jealous. I went to the first meetup. They have meetups in San Francisco or in San Mateo? No. Anyway, Silicon Valley. And I went to the first one where they talked about how the Curator was their first open source project, and they said, how do we go about open sourcing something? I said, well, you just do it. And he said, well, shouldn't I ask a lawyer or something? And they said, you can ask them. I don't think they'll help, make your code any better, but you can certainly ask them. So, yeah, it's fabulous that they've done this and open sourced all this great software for us to use. So these are, again, this diagram, but with some of those names plugged in. So the proxy that we'll be using is Zool. Their circuit breaker implementation is called Hystrix. They have their client-side load balancer is called Ribbon. What else do we have? Eureka is their service discovery. And we built on top of Turbine, which is their metrics aggregator. So some of those things, everything in red is built on top of Netflix. The ones in green come from that we've built, and I'll be showing you some of those as well. So up first, I want to talk a bit about configuration. We've created configuration server that has pluggable sources. So we first implemented Git. So your configuration files are stored in a one or more Git repositories, and they are standard Spring Boot configuration files, so YAML or properties files. We had a nice pull requests that we've added. So, oh, by the way, Spring Cloud just went general availability a couple weeks ago, so 1.0 is available. So before that happened, we had someone implement Subversion. I also have a couple other sources that I'd like to implement. So the Git implementation can have one of the requirements that seemed to come up as people started using this is that they wanted each team to have a separate configuration repository to keep configuration separate so you wouldn't have other people stepping on each other's toes. So we have per service repositories. That's not in Subversion yet, but very well could be. You get great things with Git, right? You get versioning, you get the ability to roll things back if there's a problem. You can see who made the change, when they made the change, what the change was, right? Lots of great things that happen with Git as a backend. All this is auto-configured using Spring Boot, so your Spring Cloud apps can get this, connect to the config server automatically. Pretty slick. Let's look at some demos, shall we? Let's see. So this is the code that it takes to run config server. We're not necessarily distributing executable jars. We've kind of taken the approach to make it easy for you to build and compose these services how you deem fit, or customize them, or do whatever you need to. So @enable config server, and you're good. So I have configured mine with pointed my config server at this GitHub URL. Okay, so let's get it up and running. So there we're up and running. Go to my terminal and we'll hit some pretty simple REST URL, REST API, RESTful API to config server. So it's got some Spring Boot actuator, so you can see the health of this, and you can see that it's configured to connect to, Actually, it doesn't show that there, does it? Anyway, so here is a standard call into config server. Let's see that. Let's see. Let's bring this up a bit so it's not. Is that better? A little bigger. So with this call, we're going to get the configuration for the application named My App and the label default, right? Let's see what we get back. So it went out to GitHub, pulled down the properties files that were available based on what we passed in. So there is a default configuration. You can say application.yaml or application.properties applies to everything. So if you have common configuration for all your services, it would go in here. And we got a bunch of properties back. Okay? So now, a little more specific. I'm going to get the UI component, and I'm going to get the development profile. So I specifically want, configuration for development. And so here is the configuration for the UI. Came from the MyFeed-UI.yaml. And this one is from the development profile, right? So these are, we use as the Spring profiles can be passed down into config server. So if you start an app with the development profile, it would come and get specific development properties. Let's see. And then if you want to, so this is the same, similar, but I've added another property, and this is, I misspoke when I said that this second parameter was the label. That's the profile. Third parameter that you can add is the label, and this is, in Git, it's the branch, right? So we're going to get the test branch, which I was misnamed, it was badly named, but so these are the same properties that you had before, it's just that they now come from test, so from a different branch in Git. Okay? So now let's see an app connect. So I'm going to run this UI app. Excuse me. And then we're going to look at its environment. One of the actuator endpoints that comes with Spring Boot is environment, and you can see all the properties that are available to an application. And we'll show you that this app connected to the config server and got those properties. So Java properties, system properties, environment variables, and here we are. So this is there we are. So here we have the values from config server. So they show up as a separate configuration source in Spring Boot. Just want to one of the other actuator endpoints is just some information. Any properties prefixed with info get shown up here. We added a ability to manipulate the environment for a particular application. So I'm now posting to, get rid of this guy down here. Now posting to this application and to change or add the foo property. So that just went into the environment, and if I come back up here to info, you can see that property was added to the system, right? So you have the ability to change an individual service's environment. Let's see. So this is always a fun little demo to show changing the root logging level of an application via this environment post. So if I open up this application again, it's now in debug mode and just spitting out all sorts of information. Way too much, but it's there. So if I come back, change that back to info, we've stopped receiving the debug information. So it automatically rebinds the loggers, and you can change whatever you. In fact, you see that error there is it's trying to register itself with Eureka. Eureka's I haven't run it yet, so I'm going to go ahead and turn that logging off, and those errors should stop happening now. So another thing that has been added is a refresh scope. So say you have beans that you want to react to those environment changes. So this application, I've created a service that's called feature service. It just gets a little flag whether a particular feature is enabled or not. But it's labeled with this @refresh scope annotation, which means when a refresh is called, then this bean will get those updated properties. So let's see that in action. So if I look at, I've created a little endpoint that shows feature AAA flag is off. If I change that flag to, I'll just say Devnexus, it returns that environment, that property was changed, and there's a new actuator endpoint called refresh. So if I hit that, it takes a second because we're doing the Spring context is refreshing. That's allowing that property to be updated. So give it just a second, and then if I hit this feature flag again, you can see that it's now got the new value that we added. So you can respond to these dynamic changes in your environment. We've also added a shutdown actuator endpoint. It's disabled by default. Not useful in production, but very useful in development. So there's that. So another thing that we have added with configuration servers, the ability to encrypt properties in those YAML files or properties files, and have the config server or the config client, either one, be the one that decrypts those values. So you can put, you don't worry about having sensitive information like passwords and that kind of stuff in config files. So if we look at this config file from Git, spaces, I've got this encrypted password. This is what it looks like in the config file, that cipher prefix. I don't know if you noticed, but if I call back into config server, there that value has been replaced. So the configuration server itself, or the application, gets the unencrypted value. Yes? So another way I could have done that is gone into Git, made the change, then called refresh, and it would have repulled it. Yeah, these have all been transient. Yep. Great question. Any others? There is, if you're aware, oh, go ahead.
So you have to call refresh to go get it again?
Yep.
So it doesn't like pull it or anything?
No, but that is a feature, whether it's polling or watching, some kind of push as opposed to a pull. And I'll show you something else that's a little nicer than refreshing every instance of that all at once. But yes, for now it's a manual process. But I don't think it would be difficult to add that kind of feature. So it's been requested already. So there's a Spring command line utility, and we have updated that utility to support encryption. So here I'm going to create an environment variable that I'm going to encrypt with the Spring CLI. You can see that that's that value that would plop into Cypher, and so this is one of the ways you could use to encrypt your variables, and then you can see me decrypt it back out, and we got the value that we encrypted. So that's how utility you could use. So I'm just using a passphrase here, but you can also use standard Java key stores for all of this as well. Okay, any questions before I move on from config server? So by default, well, there's a couple levels of security, right? One is to Git. So, however you lock down Git, the config server would need those credentials, right? So, username and password, SSH keys, that's all configurable. Then the config server itself can be secured using standard Spring security practices. So, if you don't want any properties coming across in the clear, you run config server on, with SSL, with security there, whatever username and password, or however you're going to secure OAuth 2 the config server, so you could configure, you can handle security at multiple levels. So, is that good? Yes, more questions. So it's just a Spring Boot service running, and it's as distributed as your Git implementation is. So, if backed with GitHub, you're as distributed as they are. Now, I have played with Zookeeper and etcd and console as potential sources for configuration as well. So it's pluggable, and there's an API that you could implement to implement whatever service you needed on the back end. More questions? Move on to discovery for the Netflix tool called Eureka. This is what they run in production. It's highly available. They run in AWS, so they have at least one Eureka in every zone, and it is aware of cross-region as well. But this is their service that you can register your services with, and it will keep track of what instances of each services are available, and then clients can ask Eureka, hey, I'd like the list of servers that this service has running. So that's basically what Eureka does. So let's go run one. So here is the discovery application. Again, enable Eureka server is really all you need. So we'll go ahead and run discovery. Let that come up real quick. So there it's running. It comes with a dashboard that I will show you. So this is the Eureka Dashboard. We just basically reskinned what came from Netflix, and you can see that config server was already up and running. It couldn't talk to Eureka, but has since registered itself with Eureka. There's a background thread that spins when it can't connect, and will continually try and reconnect. And there's also a heartbeat process that happens that if an instance of a service doesn't ping Eureka enough, it will drop it out of its rotation. So if we go run our UI again, let it come up. A few seconds, we should see another server listed here. There we go. So now we have the UI. The UI, one instance of the UI has registered itself. Okay? So the way we have it set up by default, config server is the bootstrapping mechanism. It will tell you where Eureka is, but Netflix runs the other way. Eureka is the well-known service, and it's told where, it tells you where their configuration service is. You can run either way. I'm running in the config server bootstrap mode. So that's Eureka and the discovery server in and of itself. In a little bit, I will show you how to take advantage of those servers that are running, the different instances that are running, with some of the other Netflix tools. So let's, questions about Eureka and discovery? Oh, sure. So,
I'm a client, and I want to know if you spun up another instance of a service that I'm interested in. Am I going to be notified and registered?
yeah, I will show you. So the next version of Eureka has the explicit ability to register interest, but the tools that I'm about to show you kind of handle that for you. So it will just get added to the list of servers that are available automatically. So let's see. Let's go back to presentation here. So Ribbon is the client-side load balancer that Netflix has created. It's very pluggable as well. You can have Ribbon. It does two things. It does a few things. You can ask it for a list of servers for a given service, and there are various implementations of that. Right? By default, it's just a static list that you would configure in a properties file. There's also a Eureka server list that will handle that dynamic nature of the list automatically for you. So you just say, hey, I want a Ribbon client for the UI, and it will just keep that list refreshed for you. The other thing it does is determine which server to give you, right? So it can round robin. You can also, there are some strategies for response times. It will give you, the server with the lowest response time. And you could also implement your own strategy for load balancing if you want. A lot of what Netflix has done is pretty extensible. And the next versions of these libraries are even more friendly to customize. So let's take a look at how you would connect to a client. So this is the admin application. You can see here I've auto-wired in something called Load Balancer Client, which is an abstraction from Spring Cloud over Ribbon, so you could have other implementations of a load balancer. Let's see. And here I am using the load balancer client and asking it to give me an instance of this particular service. So that's one way to directly use the Ribbon load balancer. Probably not the way you want to use it all the time by interacting directly with the load balancer. I'll show you in a little bit some ways that abstract that a little bit away from you, and your HTTP client handles that interaction with the load balancer for you. Another thing I want to show, if we come back to the presentation, is Hystrix. How many people have heard of Hystrix before? So this is one of the most accessible pieces of Netflix OSS. Doesn't matter if you're running a JVM-based application, you can use Hystrix now, right? So a lot of times it's a way to get the foot in the door for your project, even if you're not using Spring Cloud. The Hystrix, what it does is it stops cascading failure, right? And it enables your app to remain resilient in the face of, some nodes or something, some subsystem in your service failing. It has a neat dashboard, and it implements this circuit breaker pattern. So let's say this is our system, and this service goes down. Well, Hystrix will allow you to return a fallback as opposed to just dying and returning nothing, returning an error. You can say, hey, this service isn't available. They're classic, people always laugh, but for example, if the Netflix recommendation service, giving customized recommendations to you based on your viewing habits, right? If that service isn't available, it will just give you a random list, and people always laugh and say, well, it's always a random list, but you can give fallback data, right? And they talk about chaining it, so it doesn't have to be static data, right? Your fallback can go to some other service that is up. And then if that one's down, then you could return some kind of static data, for example. So if we come back to our admin application, you can see that I've enabled the Hystrix dashboard. So rather than the dashboard being a separate app, I'm just embedding it in my custom admin application. So I am going to run, let's see, a couple of applications here. So I'm running Turbine. I'm not going to talk a lot about it, but it aggregates metrics from individual nodes so that the dashboard has just one place to go for the stream of metrics, as opposed to going to every node. When you have a handful of nodes, it probably wouldn't be a problem, but when you get above that small number, it can be a big problem. So I'm going to run Turbine and feed. So this is, I didn't run the admin app. Okay, and that guy on. Like I said, it's not a trivial amount of services in this little system that I've built, but like I said, I wanted to make it something, generally there's some back-end system that only, the company has access to. Every app I've ever written has something like that. And so here's the MyFeed Admin. So this is the dashboard. There's nothing to see yet because I haven't exercised anything. But if I hit, I brought up an application. Let's see, feed. So if I hit this, my default data that I return, so the feed depends on the user service, but I haven't started the user service yet, right? So this is, sorry for that. I can see it just fine. I don't know why you can't. So this was the default data. It doesn't error. It just says, I don't know who that is, right? So if I come back to this monitor, we now have data. If I hit this enough, you'll see that it's registered a bunch of errors and that the circuit is now open, right? Just like circuit breaker in your home, it's open, there's no electricity. So at this point, if I come back and hit this some more, you'll see that this blue number went up. That blue number is short-circuited requests. These requests never even attempted to go to the user service. So there's a configurable window of time that while that circuit is open, it's not even going to attempt it. It just assumes it's down and gives you the default data. So no network call is made. So this is, you can imagine a system that is really busy. This is some back pressure that relieves some of that pressure by not even attempting to go to that system. Okay.
Does it do any toggling at all when the backend services are up?
So there's you can configure response time, with a Hystrix circuit, so you can tell it, fail if a request takes longer than this time. So you could do that kind of thing for throttling. There's various ways to configure Hystrix. They have a great wiki, and you can see all the little ways you can tweak it. So now, still down, let's bring it up. So this is a little bit of a contrived example, right? Because I just wasn't running any users. In a real example, I would have had multiple user services up, and having one of those down wouldn't have broken the circuit like that, right? So if I give this a little bit of time, so the user service needs to come up and register. So now we see we have a bunch of services. So the user service is registered with Eureka. And Ribbon also has they've configured both Eureka and Ribbon with some times to allow for network hiccups and things like that. So, come on. Oh, the circuit is still open. So, yes, after a certain amount of time, it will say, okay, I've given this enough time, I'm going to try again. No, it's still down, I'm going to stay open. Right, and now it's back, the circuit is closed, and if I hit this a bunch of times, we have successful calls again. Yep. So after a certain amount of time, it will try it again, and if it doesn't fail anymore, it will close the circuit back up and start hitting the service. So like I said, this is a great way to get some Netflix OSS in your project now, not even without Spring Cloud. You just use it directly. But questions before we move on? Okay, let's go. I've showed you the dashboard. We have been seeing that dashboard driven by an AMQP-backed queue of metrics, as opposed to the default way to do it is an HTTP stream of metrics, and Turbine connects to every single instance. And so once you get up to a certain point, we were dealing with this in Cloud Foundry that doesn't let you address individual instances anyway. So there are different ways of connecting that. So one of the things that happens in these distributed systems, these cloud-native systems, you have all these services running everywhere, and I've seen it happen. Your UI makes 40 calls to get all the data it needs, and then oh no, we need to push that back to the server, so we only make one call and we get all the data at once. But how do you combine that data then, right? So Netflix created RxJava, which is ballooned into this wonderful thing. There's a whole reactive community out there. They ported, I'm not sure of the name, they ported the library from Microsoft, which is where one of the original implementers of this. But it's push as opposed to pull. Iterators being pulling, and observable, which is what they introduce, is pushing your data. It's a nice functional abstraction. It allows clients to not deal with whether what they're hitting is asynchronous or not, right? They just deal with observables, and you can then take data from all over the place and combine it and transform it, select what you need out of it, and push it back to your service. So in this, we have our UI is going to make different calls to some of these different services. Let me show you. So here's just a simple example. We're just creating an observable from a list and subscribing to that observable and just simply printing out the names. But there are over 350 operators in RxJava for doing all sorts of different stuff. There is a reactive session tonight if you want to learn more about that kind of stuff. Go see it. But I think this is an important part of these systems to allow you to do API gateways and different things. If you're doing it in Java 7 or under, it can be a little painful with anonymous classes, and Java 8, which I've done in this project, certainly makes a ton of difference. They have client libraries for Scala and Groovy and Clojure and most languages that JVM languages you'd be using. You can use RxJava, but it certainly helps to have. So let me go here, and I can show you what I do. So let's see, did I miss? I've missed a couple things here. I have a slide missing, that's why. Okay, well, anyway, so I have this feed client, and I'll show you this client in a bit. But I say I want to create an observable of these feed items. I also want to get the user and I also want to get all the users that this user is following, right? But, you know, I put this in a NoSQL data store. I can't do join, so I'm kind of doing a join here in the application. So I filter, I transform the users. This particular call gives back a Spring MVC response or Spring response entity, and I just want to deal with the body. I don't necessarily care about the other entity. And then for each user that I get back, I want that user, but I also want all those following users, and all I get back is an ID, but I want their username. So I'm going to go back to the feed service and get the username. And when I'm done, I want to zip all these up into this thing called the feed, which is a little, just this little class down here. Little plug for Lombok. That's what that @data annotation is. They make a lot of painful things in Java easy. So I didn't have to write getters and setters or constructors. It did that all for me. And they have a IDE plugin that so compilation doesn't fail and you don't get errors. But I can just zip all this up and reference the constructor of that little feed object. So pretty interesting way of combining and getting data. Lombok, L-O-M-B-O-K. Yeah, I'm trying to remember if there's a C or not, but there's no C. Really, really cool. Google also has a tool, I can't remember the name of it off the top of my head, but it does similar things to Lombok. So this feed client, I skipped over some interesting things that I was going to tell you about. So one of them is REST template. Anyone used or heard of REST template? All right, this is Spring's abstraction there for making REST calls to other services. We have plugged Ribbon, the load balancer client, into REST template. So you'll see that this interesting URL is not a host name, right? That's the service ID. So rather, because you don't know the host name, right? All you know is the service ID, and then Ribbon parses that out of the URL, asks the load balancer, hey, give me the next one, and then reconstructs the URL using the data that it returned from Eureka to make the call. So you just get that for free when you plug in Spring Cloud. So another interesting tool is called Feign, which is one of the other Netflix tools. It is a declarative RESTful interface definition. So we've extended that a little bit to use some familiar Spring MVC annotations. And so rather than programmatically making the REST call, you describe what the REST call looks like, and then Feign handles making the REST call for you. And again, Ribbon is plugged into that so that based on this service ID that you define in this annotation. So here I'm saying I want to get from /list username, and the username is going to be substituted by this variable that I pass in, right? You just declare an interface. Spring Cloud goes and calls some of the Feign builders. Then you can auto-wire this guy into your class. And this is what I was glossing over. I just say feedClient.get feed items, right? So I didn't make a programmatic REST call at all. I just exercised the interface. Slick way of doing things. Very pluggable. Yes?
Is that appropriate for distributing, let's say, like API clients to other
I have done that personally. At the last company I worked with, I brought in Feign, and we had a separate module that defined this interface, kind of in a client module. That was published out to our Nexus repository, and the other teams would bring that in. This value here? No, it's not. When Feign is hooked up to Ribbon, it's got to know the service ID up front. But you can also configure this with a static URL, right? Which could come from a properties file. Actually, I haven't done it dynamically, so I'm not sure. But yes. Yep, great question. Others?
You could use the Spring property and inject it from
I'm not positive. But sometimes, depending on the annotation, you may have to add explicit support for putting property placeholders in it. Just from some of the Spring data, let's see, from the scheduler, actually, you can hard code a time, and then they have a different property that allows placeholders to go in it. So I'm not positive, but we definitely could add that. Great question. Others? I love Feign, and it looked like it was kind of going to die and go away, but it's recently kind of been resurrected, and they've been doing regular releases, and it's actually built with Dagger, a different dependency injection mechanism. The next release will finally get rid of that so that it doesn't matter what dependency mechanism is used. So, great. All right, where are we? How are we on time? We still got a little while. So we haven't seen the UI yet, and I haven't brought up the proxy yet. So I haven't talked about it yet. Yeah, this is one of my favorite names. I've always wondered about the naming convention of the projects, and there really isn't one. Some of them that are related to Cassandra kind of went off that route, but otherwise it's kind of a free-for-all. And Zool was really clever because Zool was the gatekeeper, so it actually works. So Zool is their JVM-based router and HTTP filter. If you're familiar with Apache HTTPD, Nginx, the Cloud Foundry Go router, HA proxy, right? It can do similar things to these services. It is fully programmable with all sorts of different rules and filters. JVM based, so you can use Groovy, you can use Java. We've made it easy to, if you have a bean that's of type Zool filter, it will just get plugged in the chain and happen automatically. I do hope to be able to, the way they run Zool, these are some of the things that they use Zool for. When they run it, they dynamically load the filters. They pull a Cassandra database. And they just recently open sourced their dynamic script pipeline. And I have an issue to integrate that, so you could load your filters from some other source than your jar class files, right? So let's take a look at our router. So ignore some of these other ones for a minute. Enable Zool Proxy. That's it. If you want to config, so we have plugged. Zool is kind of a blank slate. If you just run it, nothing will. If you just put the servlet in your app, nothing would happen. It really doesn't do anything in and of itself. So we plugged it into Eureka so that if you wanted, it would automatically create routes for all the services that are available in Eureka, just automatically. You can disable that or have certain services ignored, but we thought that was really handy to just have routes for these services. If we want to, we look at, so I have my router in my config server. That's not what I wanted to look at. Router. My service names didn't match up. When it automatically configures them, it just uses the service name as the route, and I didn't want that, so I wanted some prettier routes, so I configured each one individually. So this is just an example of how you can configure some of the routes in Zool. The left side being the service ID, and then the right side being a path or some other data. These are ant paths, if I'm not mistaken. So it kind of plugs into Spring's pattern matching library. Okay, and this is how you disable it. I didn't want, since all my services didn't match the routes I wanted, I just said, turn off the Eureka part. I'm going to do it by hand. So let's go ahead and run the router. We'll come up in just a minute. So all the requests to any Netflix service run through Zool, right? All their front-end stuff is fronted by Zool. So it's used heavily, right? I'm sure none of you watch Netflix. So that's up, and now we can see. So we've made it to my UI that was running on some other port, right? And this is the, you can show in Eureka that the router even gets registered, right? So really nice to have everything able to run through one place. Let me run, we added a actuator endpoint to this. Let's see, to the router, where are we? I've got actuator running on a different port. You can imagine if you have a default route, which I have, I say, if I come back here, I want my UI to catch anything that isn't configured otherwise. So if you have that, you need to move actuator off of the main port. So again, it can show you what's routing to where with that routes actuator endpoint. Okay. Ooh. Actually, a little bigger. So let me run. I'm going to run a couple other UIs here. Right? Because who would ever have one of having every service be the single point of failure, right? We really wouldn't do that. So I'm going to run two other UI instances. And I created a little controller. So if we come over here, give them a second to register themselves. So there's one of them. So now I have two UIs registered, and now three. Right? So we have all three of them. I wrote a little Spring MVC controller that just asked the load balancer, give me myself, and then just print it out. So we can see. So this particular response came from port 44. So did that one. This one came from 40, 42, 44, 40. Anyway, so it's kind of doing a little bit of a round robin thing there, which is the default mechanism. Anyway, so there you can see kind of the whole thing working with multiple instances. So another thing I want to cover is security. So you'll see these other annotations here. Let me come back to slides. I wanted to secure this application. Most of my demos have always been just unsecure, and I was like, that's just not real. I mean, most apps, at least some portion of the application needs to be secured. So Dave Sire wrote most of this OAuth 2 integration, but with a couple annotations and some configuration, you can get OAuth 2 security plugged into your application. So actually, let me show you what it looks like. I can log in here. It pushed me over to GitHub. We also have examples of running your own simple OAuth provider, so you don't have to go to an external service. But I've got two-factor auth here, so I need to get my little token. Of course, my phone's being slow right now when I want it. So now I'm logged in to the application, and it used my user as my key into all the databases, and this is showing my feed from other notable Spring folks. So let me show you how that happened. So I actually put this annotation in the router because that's where the interaction happens to redirect to GitHub. So I put that in, and then I can show you some of the configuration here. So this is the configuration for OAuth. These client IDs and secrets came from GitHub when you registered the application. And these are the appropriate URLs for GitHub. So most of that information is just getting the right information from your OAuth provider and sticking it in these values. The application that is secured is the UI. So we come back to the UI, and you put this, the OAuth resource on it. And so this says we have the router, it knows that if to forward the OAuth token appropriately to the backend service that it needs. So that's, and then this, if we look at the UI's configuration, we plug in just that little part about the resource. It doesn't have to know about actually authenticating, but just validating the token that it gets passed. Okay? I've told you all I know about security, so we'll move on. Any questions before we move on? Okay. I want to talk a little bit about, so someone asked about the refresh earlier, and just, you know, I was poking one node to refresh, right? So, close that. So we've created this thing called the bus. I like to think of it as distributed actuator, right? You have these actuator actions that these endpoints that you can poke on an individual node. Well, these actuator endpoints, when you poke them, they poke everyone, or they poke all of the instances of a particular service. Okay, so we have implemented two distributed endpoints, that env that I showed earlier about changing an environment variable, and refreshing once you get that change. So it uses standard Spring modules, Spring messaging, and Spring integration. Currently, the implementation is based on RabbitMQ, but because of our use of Spring integration, you could build it on anything that you could wire into Spring integration, right? So, someone asked for Kafka support, right? Or whatever messaging system you happen to be using. I've actually built an implementation with Console because it has built-in messaging. So, this is just an abstraction over those messaging endpoints. So let me show you. Do a quick little demo here, if I can. Where are we? So this is kind of fun. I showed you that logging demo before. So we're just going to change we're going to just debug every service that's running. See what happens. I come back here to IntelliJ. Like I said, it's going through and refreshing the Spring context. So now our UIs, of course I'm just going to bring my system to a crawl because now every app that I'm running is spitting out massive amounts of debug information. So I'm going to turn that off. So there, and it stopped. But pretty simple, right? Send a message to a topic in RabbitMQ. Each of the services pulled that message off the topic and executed some little bit of logic that we have automatically configured via Spring Boot and Actuator. Okay, so let's do one more. Just some other arbitrary value, and you can see here that we received this remote environment change. We're going to update this value, and then if I called, I'm not going to do it, but you could send the refresh, call bus refresh, and it would do refresh on every node, right? But pretty simple way to do that. Let's go back. What if you don't use Java in all your applications? Or Java at all, for that matter. I guess it could work. So Netflix released something called Prana, which is a sidecar. I had a good conversation with a fellow named Andrew Spiker that was an IBMer that is now a Netflixer. Is that a term? And they created this sidecar, and I said, well, with Spring Cloud, that would probably be really simple. We already have proxy enabled. We already have configuration that is distributed and remote and accessible over HTTP, right? So non-JVM apps can hit that. So in a relatively small amount of code, I created this sidecar that you can run alongside a non-Java application and get all the value. There's an API for, well, we're getting close to running out of time. Let me see what, let me run the sidecar, show you, again, at enable sidecar. Now, in the sidecar, you have to tell it about what port your non-JVM app is running on so that it can correctly register that port with Eureka so that when other services ask for your non-JVM app, they get the right port. And then there's a little bit of health plugged in there. But I created a simple REST API to basically as a pass-through to Ribbon. So you can ask, oh sorry, it's my fingers, sidecar. I don't have that port in my head. Did I see a hand? Oh, okay. So if I ask for, what's available for the UI, I can get back this list, and then of course you don't have the Java implementation of Ribbon, right? So you could, your app would just have to pick one of these to try, and it's also a proxy, so I can go to the config server for my app. You know what? I'm a Ruby app. I want YAML. I don't want that. Oh, of course it doesn't work. What am I missing? Oh well, something had to fail. So there is a way to ask for the values from the config server in a YAML document as opposed to just getting that JSON document back. So that is sidecar. Some of the things that we've been thinking about, right? We haven't made any. This isn't a roadmap. This is just ideas. But doing things that other distributed systems do, like locks or leader election, potential alternate implementations. I've done one with console for discovery, configuration, the bus, the locks. It's already a sidecar. It's got a lot of neat properties. It's multi-data center aware by default, and it's the only other system you'd have running besides your code. So it's pretty slick. You can do some of these things with Zookeeper. I've been playing with Zipkin for distributed tracing, right? You have this big system, and you make a query, and it's slow. Well, where is it slow? And so with Zipkin, you can visualize where that actual slowness is happening through your distributed system, right? Pretty neat. We want to use this bus more, give developers more integration with it. So those are some of the things we're thinking about. with that, I think I'm out of time. So thanks for listening.